Hey guys, welcome back. So this is kind of the note portion of our ecology unit. You should be able to learn most of what you need on this unit by performing that biome project, that group project. But here's kind of a little bit of filler that will help connect some dots for you. So the first thing I want to talk about a little bit is this is kind of the base of what really defines an ecosystem. It starts with the weather. Weather is basically just a short-term description of an area's precipitation and the wind and temperature and all that. It's very short-term. As you've seen from living in Kansas, it can actually change by the minute. Example of how to describe it might be clear, cloudy, raining, snowing, hot, things like that. You might also talk about its humidity, its temperature, its wind, its all that. That's different from climate in that, unlike weather, climate's going to, weather can change daily. If you take those trends, like what happened last year, and the year after that, and the year after that, you can start to draw some patterns and trends. Those patterns and trends over like a 30-year period, that is the climate. So you might describe like, well, I'll give you an example here in a minute. These are ways that we describe weather. Sunny, so we might go sunny, mostly cloudy, partly mostly cloudy, a single cloud. Rain, lots of rain. That actually has to be hail because this is snow. Thunderstorms or tornadoes, snowing, and a chance of balloons. This would be how you describe the climate. It's the long-term kind of trend we see over a 30-year period. For example, if you take this kind of portion right here in Africa, up in the northern portion, you'll see it's a very, very dry desert. There's a very short rainy season. It's very dry for the most part and very hot. Down here in Brazil, you have very, very wet, temperate areas where it goes from hot to mild back to hot. You don't get a whole lot of actual seasons in these tropical, I hope maybe I didn't call it tropical grass. This is a tropical forest. It's to be a tropical grassland. They're so close to the equator that their temperatures don't really fluctuate much, as opposed to places away from the equator. They flux a lot and they get really hot and really cold, not day to day. So what is the weather? Well, today it's very cold. It's January 19, 2016, and it's very cold, very cloudy, very windy. There's a little bit of precipitation, just enough to kind of put raindrops on your windshield and freeze them. So luckily, that's not how it is every day. We're in the middle of winter. So, a few days ago, it was actually like 60 and sunny with no clouds. Today, it's very cold, very cloudy, very windy, and kind of wet. The climate for Wichita, you have to actually use these biomes to describe it. And we are actually in a temperate grassland, which means that our climate goes from, let's start at the beginning of the year. It kind of goes from a nice spring, which is very wet and mild, 75s, just water dumping down on us. And then we go to a summer, which is stormy at first, then very dry and very hot. Then we go into a fall, which now the air is mild again, 75s, but extremely dry from just coming out of the really, really hot summer. That's why it's real fun to put on those cozy, snuggly hoodies. But in the fall, you shock yourself and everything because the air is so crazy dry. So we have mild fall, mild spring, wet spring, dry fall, and then a very, very cold and soggy kind of winter where we get temperatures down, below freezing. Contrary-wise, in the summer we get temperatures above 100 degrees. So we have a true summer, a true winter, a very hot summer, a very cold winter, sandwiched between a mild, wet spring and a mild, dry fall. That's our biome. That's how we describe our climate. One other thing that regulates the climate is not just its geographic location close to the equator. If you have those big fluctuations, like I talked about the grassland, we call that temperate, experiencing 4 seasons. If you just go from kind of hot to kind of hot back to hot, like really close along the equator where you don't have full seasons, we call that tropical. One thing that helps regulate this is this greenhouse effect. Now, you heard a lot about greenhouse gases and things like that in the news. A greenhouse effect is just that. It works like the glass greenhouse that maybe you've seen. Greenhouses are made out of glass, and the greenhouse effect is made out of gas. With a glass greenhouse, plants like it to be warm and it needs sun. So it's really kind of a simple invention, really. Just build a house out of glass. Light comes in, light comes out, heat goes in, but heat can't get out. So it's a very simple process. In our case, our atmosphere is not made of glass, but it is a transparent gas. So heat or light comes in, light goes out, heat comes in, and some of the heat can't get out. Depending on how thick this greenhouse gas layer is, will tell you how much of that heat gets trapped. As we continue to put greenhouse gas into the atmosphere, it traps the heat more efficiently, and heat can't escape. So this is another big player in the temperature regulation of our planet. Do not confuse this with the ozone. We breathe in O2. The ozone is made of O3, and it's a layer of ozone gas that basically helps block UV radiation, completely different from the heat. And don't let that be confused with the electromagnetic poles we have. We have a north and a south pole that actually have a magnetic signature to them. When solar radiation, so when the sun sends solar radiation down to us, those poles actually block it off and send it back to space. And it's when you see the solar radiation hitting our magnets, you see the northern and southern lights. So when you see the northern and southern lights, you know that our magnetic pole is working and it is deflecting radiation back into space. So with what you know about greenhouse gases and greenhouse effect, I ask you, which is the hottest? So I'll let you pause this video and look at it for a second and think about it. So now that you've had a chance to do that, you may have a few answers here. Well, if you answered Venus or Mercury, you're wrong. The sun is the hottest. Boom, roasted. Okay, so which planet is the hottest? Right here, Mercury is the closest. It is not the hottest. This is Mercury right here. You can see it's a dense ball out in space. It has no atmosphere. So although it gets very hot, there's no way to trap the heat. There's no greenhouse effect. This is Venus. Venus has a very, very, very thick atmosphere, much thicker than ours. This is what some astrophysicists call a runaway greenhouse effect. It is extremely hot. So this is basically, if the sun is the heat source, this is with the oven door open, and this is with the oven door closed. Super crazy hot. I have a joke, but I don't have time to go into it. Oh, okay, I will. Venus is the planet that represents women. It is hot. It is spicy. It is fiery. It's very bright. It's extremely dangerous. It can kill you. It will burn you. Yeah, so no, hell have no scorn like a woman's revenge, right? Ironically, it's also the only planet that spins in the opposite direction, or the wrong direction, proving that women are always incorrect. Of course, if you ask a woman that, she would say that she's the only planet spinning in the right direction. So, pretty perfect. All right, let's talk about these right now. We have abiotic and biotic factors. Given this given these climates right here, that will determine what kind of life forms can live in those areas. So biotic, as the name suggests, this would be things like the plants that can live there. You don't see cactuses in the tundra. You don't see moss and lichens in the desert. And so the climates will determine if you have trees and grasses and things like that. Then the plants will determine the kind of herbivores you have. The herbivores will determine the kind of carnivores you have. The abiotic factors are the non-living things: temperature, humidity, precipitation, sunlight, weather. These things together will basically determine how well an organism can survive in that. And they, more importantly, that was a bit redundant, they more importantly determine the productivity. A tundra doesn't have a whole lot of sunlight. It doesn't get very hot. It's very cold. There's not a ton of precipitation. in liquid form, so there's not a lot of life to be supported. On the other hand, a desert, or a rainforest, which is really close to the equator, has lots of rain, lots of sun, lots of nutrients, and it has a much higher productivity. It can support way more life. We always talk about the biodiversity in a rainforest, not a lot of biodiversity in the tundra or the desert. Basically, a habitat is where animals live. It's its home. And to determine what kind of habitat you'll have, you have to take those biotic and abiotic factors. And that will describe an animal's habitat, where it lives and what it eats and what eats it. Well, if the habitat is its home, the niche is its job. What do they do? It's unfortunate, but a lot of organisms' job, their niche, is just to be food for other animals. Grass basically just grows so that it can be grazed on by deer-like animals. Many rodents and small animals like that are just basically food for other animals. And then top-level predators, their job is basically just to keep those smaller predators or smaller prey in check and make sure they don't get out of control. So how would you like to have that for a job? Let's see here. Resources, anything that basically form competition. It might be mate. It might be space. Rainforests have everything you ever want. They've got rain. They've got heat. They've got lots of biodiversity, but it's so competitive for space. It's kind of like New York. It's got all those amenities, and the only thing it doesn't have, it's crowded. So they're always looking for new places to build. So that's that. I'm going to let you look at this thing in the textbook here, page 101, the competitive exclusion principle. This basically says that you can't really have two animals that occupy the same niche in the same habitat at the same time. The example they give of these birds, and although you might think, well, hold on, there's all those birds live in the same tree in the same habitat. So I'll give you a second to find that in your red macaw book. Those birds actually occupy very different niches. Some at the top of the tree, the bottom of the tree, the middle of the tree. Some eat the berries that are in the branches. Some eat the stuff that falls down. So they actually, even though they live in the same habitat, they don't actually have the same niche. They do slightly different things. If they did the exact same thing, they would compete and push one out, or they would be excluded. That's the name. So let's talk about this. I've got about 3 minutes left. Predation and prey. This is pretty easy. The one that does the killing is the predator. The one that does the eating or becoming eaten is the prey. Like this. This big, long carpet boa is the predator. That deer is the prey. I hope she doesn't have any antlers, so that's going to be a rough time. So predator, prey. Symbiosis. If you look at this, sym means same, bio means life. They live in the same space. There are 3 forms: mutualism, commensalism, and parasitism. Mutualism is like a boyfriend-girlfriend. They both benefit from the relationship. It's a mutual existence. This honeybee here gets nectar from the plant, and he inadvertently grabs pollen from the flower and spreads it around. He gets a free meal, he spreads the pollen, everybody wins. It's a plus-plus. Commensalism is where one species benefits, the other one's not really affected much at all. So, like, you have this cattle, this cow of some sort. He walks around grazing, and these little cattle egrets here, they basically wait for this guy to scare up little insects, and then they eat them. So he's not really affected at all, but these birds, just by being there, are able to get a free meal. So that's an example right there. This is a gross one. Parasitism is when one species benefits, the other one is hurt. So this is a big, fat, nasty tick. Look at the size of that person's fingernail compared to this. This is the parasite here is called it's the parasite. Whatever it's attached to is called the host. Typically, the parasite is much smaller than the host, and they often are very detrimental to them. Important thing that should be said: a really good parasite will not kill its host. Remember, symbiosis, living together. You kill it, you're not really doing symbiosis. You're doing predator-prey. So there's some examples. Well, these two are about the same size. Predator, prey. This is predation. This is much bigger than this. This is parasitism. This right here, you can feel free to pause these and take a look at. Pause. Okay, this would be mutualism because these guys hide and get protection, and then they pick off little bugs that the enemy can't really get to. So everybody wins. This is predation. Yikes. Look, he's still smiling. These barnacles get a free ride. So this would be, and a whale's not affected. So think what that would be. This looks like predation, but this one is basically just giving this little crocodile a trip to the dentist. So think of what that would be. Free food, not affected. This one, I'll leave you to interpret. You think about this.